Good morning, ma'am.
Very good
Good
morning.
morning, ma'am.
Very good. Yes, very good morning. Okay, so we started with series circuit. In series circuit, the resistances, the total resistance will be sum of the resistances, and in series circuit, the current will be same. Okay, but voltage will be divided between the resistive elements. Okay, similarly, for parallel circuits, the net resistance will be, or the total conductance will be some of the conductances present in the circuit. And then in parallel circuits, the current will be divided and the voltage will be same. Okay. So we had taken, and then current divider rule, voltage divider rule and current divider rule. So in series circuit, voltage will be divided. So we can find it using the voltage divider rule. So if suppose you have two resistors connected in series, then voltage across any particular resistor will be equal to the total voltage multiplied by the same resistance divided by the sum of the resistance. Similarly, for the parallel circuit, if you have two resistors in parallel, as per the current divider rule, the current flowing through any resistor will be equal to the total current multiplied by the opposite resistance divided by the sum of the resistances. Okay, so based on that, there are two problems. I do not know whether we discussed this. Okay, same thing. So here the total current is given. So the total current is given and the two resistors values are known. Okay, so you are asked to calculate what is I2. So simply by using the current divider rule, I2 is equal to total current. Total current is 6 amps multiplied by the opposite resistance. What is the opposite resistance? 4 kilo ohms divided by the sum of the resistances 8 plus 4, 12K. So K and K will get cancelled. So that is 2 amps. So what will be the current flowing through this? 2 amps. So obviously this current will be, so out of the 6 amps, 2 amps is flowing through this 8 kilo ohms resistor. So the remaining 4 amps will flow through this. The same way I can find. Same way here, you're asked to calculate what is R1. What is R1? So here this current is known. This current is known. So now, how do I do this? Can anyone tell me? How do I find this R1? How do we find this R1? Anybody?
Find the current flowing to R2.
Okay, so I find the current flowing through R2. Yes. So what will be the current flowing through R2? You can tell me the answer. 6 milliamps,
6.
right?
Yeah.
Because the total current is 27, so 6 milliamps. So now I can find the voltage drop across this. So what will be the voltage drop? 7 into 642. What is the unit? Millivolt. So here for the parallel network, same voltage will be available over here. So from that voltage, that is 42 millivolt, and I know the current 21 milliamps. So what is the current? 42 divided by 21, which is nothing but 2 milliohms, or it is 0.02 ohms. Okay, so that way we can calculate the, sorry, current is milliamps. So obviously this is 2 ohms. Okay, so this way I can calculate. And then another interesting factor is, as discussed already, for parallel circuits, you have the same voltage. So let us forget about the network. If suppose we are connecting two batteries in parallel, if suppose we are connecting two batteries in parallel, we are connecting two batteries in parallel, then obviously if they have the same voltage rating, they can be connected in parallel. Because for parallel, I think one of you is unmuted. Please mute yourself. There is a small disturbance from one or two. Please mute yourself. Okay. So here, if you have two batteries connected in parallel, then if they have the same rating, then there is no problem. When two batteries connected in parallel, if they have the same rating, then there is no problem. Okay. Otherwise, if suppose two different rating batteries are connected, okay, one reason, before we see the effect, one reason why we connect these kind of batteries, that is same rating battery connected in parallel. Why we connect this? To increase the output current. That is here if I connect the load, no. So when I connect two batteries in parallel, the load current or the current supplied by this net battery to the load will be more. Because in parallel circuit, that is when I take a single battery, the current supplied will be I1. Okay, if suppose I connect two batteries in parallel of same rating, then this can supply one I1, the other battery can supply I2. So the net current flowing through the load is going to be I1 plus I2. So if you have same rating batteries connected in parallel, then there is no issue. The purpose of doing that is to have a higher current rating or to have a or to increase the drivability. What is the meaning of increasing the drivability? Higher load current will be supplied to the load. So if suppose my load needs more current, then I can go like this. Okay. So now let us go for, if suppose we connect two batteries of different rating in parallel, what is going to happen? Okay. So the effect is one could be, it will be ineffective, or the other possibility is can be damaged. Okay, here we have taken I have taken an example to explain how it can damage. Okay, so here two batteries are connected in parallel. So two batteries are connected in parallel. So one is 12 volt, the other one is 6 volt. Okay, so because of this difference, there is going to be current from higher battery to the lower battery. Okay, so here the internal resistance is 0.03. Here the internal resistance is 0.02. Okay, so now there is going to be, because of this difference in potential, the current is going to flow from here to here. So now what is the current value? 120 amps. So imagine 120 amps flowing through this, definitely this will be damaged. Okay, that is the reason generally we don't prefer to have two different voltage sources or two different rating batteries connected in parallel. So if we connect that, either if the difference is very small and the current is not going to affect the circuit, there won't be any effect. Otherwise, if it is like this, if the situation is like this, then there is going to be a damage in the circuit. Okay.
Excuse me, ma'am.
Yes, ma.
Ma'am,
Mm.
in that 12-volt battery, ma'am, on the left side, if we keep that on the right side, then the current will flow in the 6-volt battery?
No, yes, if exactly. If you swap, no, that's what you're asking, right?
Yes,
If you
ma'am.
swap, that's the question, right?
Yes, ma'am.
Yeah, the current will flow in the opposite direction from 12 volt to 6 volt. The question is, I guess.
Okay, okay, ma'am. Thank you, ma'am.
1 minute, sorry.
Yes.
So here, if suppose I'm connecting 6 here and 12 here. Okay, so 12 here, 6 here, then obviously current flow like this, and definitely again here there will be a same high current 120 amps. This will get damaged.
Yes, ma'am. Thank you.
So now we have open and short circuits. We have another two terms, that is open circuit and short circuit. What is meant by open circuit? That is when there is no load is connected. I have a battery or I have some source. Now the source is left open. That is, we haven't connected anything. So this is called open circuit. Okay. So when there is no load connected, assume that I have a source here. Can anyone tell me what will be the current flowing through this open circuit and what will be the voltage across this open circuit? I have my voltage source. I have my network.
Zero,
Okay.
ma'am.
Zero.
Which is zero? Which is zero?
Current is zero.
Because there is no closed path. This is open, so there is no closed path, there is no current flow, my current will be zero. So obviously, since there is no current flow, there is no drop across this, so potential at this terminal and this terminal will be same. Sorry. There is no drop across this, so my potential will be whatever is available over here. Whatever is available at A and B will be available over here. So in open circuit, if I have simply a voltage source, open circuit voltage will be equal to VAB. Okay. Similarly, we have short circuit. That is, I have my voltage source. If we are short circuiting these two terminals. Okay. Now, what will be the current and voltage? What will be the voltage and current? So since it's a closed circuit and because we have only internal resistance, okay, we don't have any load here. So the current will be maximum current, whatever it could supply. Okay, whereas the voltage will be, since this is shorted, the potential at this, there is no what to say, there is no drop across this because this is a wire. Okay, so the potential at this terminal and this terminal will be same. So the potential difference between these two terminal will be 0. Okay, during the short circuit condition, there is going to be a maximum current, but the voltage will be, because it's shorted. So whatever is the potential available here, the same potential will be available at B also. Or I can say these two are same only. If I say this is grounded, then this terminal is also grounded. That's what is the meaning. So the voltage or potential difference across the short circuit will be 0. Okay, so that is an example given here. What is this current? Can anyone tell me what is this current? Can anyone tell me what is this current? You need not solve. You can say directly the answer.
12 milliamps.
Very good. Since here we have two resistors and this is 0 resistance. Ideally, wires will have 0 resistance. So this current directly will go to this. Okay, because this has a minimum resistance, the current finds a path directly over here. So the total current flows over here. So this is 12 milliamps. And what will be the voltage here? What will be the voltage here? This is 20 volt. In open circuit, since it's an open circuit, my total voltage will be available over here. That's what is the concept of this open and short circuit. Okay, so now I have taken some of the parallel networks and how do you calculate the total resistance? Okay, so as per the discussion, for parallel networks, for parallel circuits, the resistances are connected in parallel. So here the total resistance will be, or the total conductances will be sum of the individual conductances. So here I can go for, you can just remember that expression, that is when you have two resistors connected in parallel. When you have two resistors connected in parallel, that is R1, R2 divided by R1 plus R2. But the interesting thing here is, it's not different values of resistors, all the resistors of equal value. If you remember, can anyone tell me, if you have equal resistors connected in parallel, what will be the net resistance?
R by N.
R by N.
R by N. Very good. So here R is 12 ohms and 3 resistors are connected in parallel. So N is 3. So it's 4 ohms. Okay. Similarly here, how do you solve this network? See here, if you look at, so 6 ohms and 6 ohms. Oh, sorry, 3 6 ohm resistors are connected. If you look at this, 3 6 ohm resistors are connected in parallel. If I have any series here, then that is definitely cannot be simply called as parallel network. That's a series parallel network. Now for this parallel network, I can obviously swap. Okay, I can swap. Nothing wrong in that. See, I can just connect the 3 6 ohm resistors together, and then here 9 ohms and this is 72 ohms. Can anyone tell me, when you have 3 6 ohm resistors connected in parallel, the net resistance will be R by 3. So it will be 2 ohms. And then when you solve this 9 ohms and 72 ohms connected in parallel, that will be 9 into 72 divided by 81. That is R1, R2 divided by R1 plus R2. Can anyone tell me what is the answer?
8.
Yeah, it's 8 ohms. Okay, so again, when you try to reduce 16 by 10, it is 1.6 ohms. So what is the effective resistance? It is 1.6 ohms. Okay, then it's a very simple example. A very simple example. Here a parallel network is considered, and then you have two resistors connected in parallel, and you are asked to calculate the total resistance and the total current, and current supplied, current flowing through the individual resistors determine the power across each resistive load. Okay, and then power delivered by the source and compare it to the total power. Obviously, the total power will be sum of those two. In series circuits, because of the voltage variation, you will have different power dissipation. Whereas here in parallel circuits, because of the current variation, we'll have the different power dissipation, and total power supplied by the source will be equal to the total power absorbed by the loads. Okay, so you can solve it, I guess, easily. Then here, here I think, you're asked to calculate R3. I hope we can solve this question. Okay, so here the question is, the total voltage is also not given, E is also not given, but still your total resistance value is given. Your total resistance is given as 4 ohms. And then current flowing through this is given as 4 amps. This current is not known and R3 is also not known. Okay, so how do I compute? Which parameter should I proceed first? Which parameter should I do first?
R3.
R3, okay. Because the total resistance is known, I can go for R3. Very good. So what is R3? Can anyone tell me? When you solve this 10 ohms in parallel with 2 ohms, that will be 200 by 30 by 30 will be 20 by 3. Let me keep it as 20 by 3 itself. So 20 by 3 into R3 divided by 20 by 3 plus R3, which is equal to 4 ohms. Okay, so now can anyone solve this and tell me what is R3? Can anyone solve this and tell me what is R3? Anybody? 80 by 3 plus 4 R3. 80 by 3 plus 4 R3, which is equal to 20 by 3 R3. So 4 R3, sorry, I missed R3 now. 80 by 3 only. It's not R3, 80 by 3. So 4 R3 minus 20 by 3 R3 is equal to 80 by 3. So when you solve this, 12 minus 20 minus 8 by 3 R3, which is equal to 80 by 3. Okay, so 3. So R3 is minus 10. Am I getting minus 10?
I've gotten minus 80 by
No,
R3.
ma'am, it's plus 10.
Plus 10.
Plus 10. I did some error, I guess. Okay, so 10. So R3 is 10 ohms. Okay, so now I know the R3 value. So now, which one can I proceed now? Which one can I proceed now? I. Is it for I2 or IS? IS cannot be determined because we don't know the voltage. Okay, so now it's easy to find out what is I2. What is I2? Can anyone tell me what is I2?
2 amps.
Sorry?
Yeah.
2 amps.
2 amps.
2 amps. How did you find that is 2 amps?
Ma'am, by equating the voltage.
By finding the voltage, because we know the this voltage across R1 will be 40 volts. 4 amps into 10 ohms is 40 volts. So definitely voltage across this will also be 40 volts. So obviously this current will be 2 amps. Then here also I have the same voltage 40 volt, and what will be this current?
4
amps. So now what will be the total current? Total current will be summation of all these currents, right? So 4 amps plus 2 amps plus 4 amps. So it will be 10 amps. Okay, so now I know this. So what will be the total voltage? So this will also be 40 volt. This will also be 40 volts. Okay, so I think we found everything. Okay, so determine P2. P2 is the power dissipated across this. So I square R2. So I is 2 square into 20. That is 4 into 20, 80 watts. So we are able to calculate all the values. Okay, so everybody is able to do this, right? Any doubt for anyone?
Ma'am, actually the wires are like not connected to each other, ma'am. Like they're earth, ma'am. So why are we like it's parallel only, but it's really different from the normal case, ma'am.
Sorry, ma, it's parallel. What is the doubt?
Parallel, but actually the wires are earthed into the ground, ma'am. So it's different from the normal case.
No, it's not different from the normal case. See all this. All these so if I name this is terminal A and terminal B. See, all the terminal A's are connected together. This is a common point. Similarly, this is also a common point. You can consider this as short. That's grounded. That's what is the meaning here. All the other end of the resistors are connected together, and that's connected to the negative terminal of the battery, and negative terminal of the battery is grounded. This is equivalent to what is given there in the circuit. This is equivalent to what's given there in the circuit. Why
Yes,
there's a confusion? Because of this ground node? No confusion, right? Since it's a ground, all are it's nothing but all are shorted. So we have this is a terminal which is common for all the 4 elements. Again, here this is a terminal which is common for all the 4 elements. So obviously it's for all the 4 elements are in parallel. Okay, so series network, parallel network identification is very easy. When you have series parallel network, there only we'll have some difficulty, not for all the circuits. For some networks, it will be a little difficult to solve. Okay, now series parallel network. Okay, so first we discuss series network where we have what to say, all the elements connected in series. Okay, then we discussed parallel network where we have all the elements connected in parallel, whereas here we have networks that contain both series and parallel configurations, Okay, so here I have given an example over here. See, if you look at this network, so now see between B and C, if you consider terminal B and terminal C, so now this is a common terminal between these two elements. So obviously this is a parallel circuit or parallel network. Okay, now when I try to reduce this parallel network to a single equivalent resistance, then these two are series. When two elements are connected to a common terminal, when two elements are connected to a same terminal, then that is a series network. So this is a series network. So I have to go for reducing this using parallel, then go for a series. Okay, so how do we reduce this? I should first reduce these two which are connected in parallel. So 12 kilo ohms connected in parallel to the 6 kilo ohms. Okay, so 72 divided by 18, which is nothing but 4 kilo ohms. Okay, and then here we have another 2 kilo ohms connected in series. Now I can easily solve. To this. Okay, so my total voltage source is 54 volt and these two are connected in series. So I can reduce this to a single resistor. I can reduce this to a source connected to a single resistance. Okay, so here this is a very simple circuit. Like this, we can have any series, any network consisting of series parallel combination. See, this is another example. So for any network, we have to first identify the series configuration and parallel configuration. Try reducing it. Okay, so here the question is, you are asked to calculate what is the current IA, what is the current IB, IC. Okay, and then you are asked to calculate the total current also, current supplied by the source also. Okay, so now, okay, so IB. Okay, so now these two are in parallel. That is 4 ohms and 4 ohms is in parallel. So I can reduce to a single resistance and that will be the current flowing through this branch. Okay, so here 4 ohms and 4 ohms is connected in parallel. So this can become 2 ohms. And then in the another branch, I have two resistors R4 and R3 which are connected in series. So now in series connection, we have total resistances, sum of the resistances. So 1.5 ohms and 0.5 ohms. So that becomes 2 ohms. Okay, and then here we have another resistor 4 ohms. Okay, now I have a voltage source here. Okay, so now I can find all the other values, right? So what will be the total current? This is the supply current, right? This is the current supplied by the source. Very good. Because these two are connected in parallel, so that becomes 1 ohms. So 1 ohms plus 4 ohms. Let us, if I reduce further. So this becomes 1 ohms and this is 4 ohms. And obviously this is a source. So 10 volt source and this will be 5 ohms. So the current will be, IS will be 10 divided by 5. So 2 amps. So I reduce here 2 amps. So my IA is 2 amps. And what will be your IB and IC? So obviously this total current is divided between these two branches because these two are connected in parallel. Okay, these two are connected in parallel. But very interesting thing here is these two resistors of equal value. So I need not go for current divider and all. Directly I'll be able to write this 2 amps current will be divided between these two equally because the resistances are equal. So I can directly say that 1 amp and 1 amps. Okay, so I need not go for the current division because these two are equal value. So my total current 2 amps is divided between these two equally. So 1 amps and 1 amps. Okay, so any doubt here in this? Now I have taken few more examples. Okay, so with this series parallel combination, can you try? These are all not so easy. Okay, so this is an example. This is an example. This example is just to explain you in some networks. In certain networks, it will be easy to solve when you redraw the network. When you redraw the network, these two are not two different networks. This network is redrawn like this. This network is redrawn like this. How did I got this? Means how did I get this? Okay, so here I name this as terminal A, and these two are same. No, these two are A, same, right? So I named as this is A and this is B. Okay, as of now, let us forget about this ground connection. Let's forget about this. These two are connected together. Okay, so what do? I name this, I just rotate the circuit. I just rotate the circuit 90 degree. Okay, so what do? Top I have A, at the bottom I have B. Okay, so there is no confusion in connecting the resistors. You connect as per the circuit. Now the source alone we will see. Now the two batteries connection alone we will see. Okay, so now here at A we have 6 volt. And then here this positive terminal is connected to again the positive terminal, and this negative terminal is connected to B. Okay, any confusion here? Any doubt here in redrawing the network? That's all. So what did I do? I have taken this as A and this as B. Okay, and then these two are connected together. So I have just redrawn I have rotated the circuit 90 degree and redrawn the circuit like this. So now this is what value of the source is this. So now what will be the net source? I try to combine the voltage sources connected in series. Can anyone help me out? How do I do this? Will it be a positive voltage source at terminal A or negative voltage source at terminal B?
Positive at A and
Positive terminal.
At A. Okay, very good. So now positive. Since my 18 volt is more than 6 volt. Okay, so now definitely the net voltage will be the difference between these two. Okay, now since 18 is higher, I'll have 12 volt. So A will be plus 12 with respect to B. A will be plus 12 with respect to B. Okay, now I can redraw this. Now I can redraw this. So as per this, A is connected to 6 ohms in series with 2 ohms and 5 ohms in series with 3 ohms. I think you can, because these two are in parallel, no? You can just swap the branches, nothing wrong. So now the question is, you're asked to calculate this VAB. You're asked to calculate this VAB, the voltage drop across this. Okay, let us not confuse this with AB. Okay, so this is A and this is B. Okay, just to redraw, I have taken this as A and B. Okay, so but here in the original network, they have given these two terminals as A and B. These two terminals as A and B, and you're asked to calculate VAB. Can anyone tell me how do I do this VAB? My total voltage is 12 volt. So obviously, we don't have any series resistor, so there won't be any drop across. So this will be 12 volt and this will also be 12 volt. Okay, so now we know that this 12 volt is divided between these two resistors. Am I right? So how do I do that? What is VAB? Can anyone help me out? What is VAB? VAB is potential difference between these two terminal, which can be written as VA minus VB. The potential at terminal A minus the, how do I say VA minus VB? Since they have given positive at A. So they are measuring the voltage at A with respect to B. So that's the reason I'm writing it as VA minus VB. Okay, so voltage with two subscripts and single subscript. We discussed in the last class, right? So now what is VA? Can anyone tell me what is VA? VA is voltage at terminal A with respect to this reference node. With respect to this reference node. So which is nothing but voltage across 2 ohms resistor. Voltage across 2 ohms resistor is VA. Voltage across 3 ohms resistor will be VB. So now VA minus VB will be VAB. Okay, so now how do we find out this voltage? How do we find out this voltage? Can simply go for voltage divider rule. What is VA? VA is the total voltage. What is the total voltage? 12 volt multiplied by the same resistance divided by the sum of the resistances. 6 plus 2 is 8 ohms. So it is nothing but 1 by 4. So 3 volts. VA is 3 volts. Same way, apply the voltage divider rule and find out what is VB. So VB is total voltage multiplied by the same resistance divided by the sum of the resistances. Again, here we are having the same voltage. Sorry, 3 by 8. So what is the value? This is 3, 2. So it is 9 by 2, 4.5 volts. Okay, so VA is 3 volt and VB is VAB will be 3 minus 4.5. So it is nothing but minus 1.5 volts. So I'm able to solve, I'm able to find out what is VAB. Okay, so other than that, there are some other questions. You are asked to calculate what is V1 and what is V3 and what is I1 and I3. Okay, so can anyone solve and tell me the answer? Should I explain this or you will be able to do it? So if there is silence, I assume like you all are able to do.
We can do it.
Ah, very good. Okay. So if anybody is having a doubt, please interrupt me. Otherwise, I'll just continue with the next network. Okay. So
VAVB.
sorry, ma.
VAVB, how did we find?
That's what no. So the question is given as this is VAB. This is VAB. So now VAB, what did I do? I just consider this is voltage at A and this is voltage at B. So the voltage difference between these two is nothing but since I measure the voltage at this with respect to this, I consider this as the potential difference between A and B. So VA minus VB. What is VA? VA is voltage at this node with respect to this reference node. Okay, which is nothing but the voltage drop across 2 ohm resistor. Okay, and I have a 12 volt source here. So these three are connected in parallel. So here also I have the 12 volts. 12 volts. So just apply the voltage divider rule and find out the voltage drop across 2 ohm resistor. I got it as 3 volt. Same way, here also I have 12 volts. Just apply the voltage divider rule. Find out the voltage drop across 3 ohm resistor. Okay. Now what is voltage drop across 3 ohm resistor? VB. What is voltage drop across the 2 ohm resistor? VA. So VA minus VB. Can find. Okay, now V1 is nothing but 12 minus VA and V3 is nothing but 12 minus VB. That's all. We got the values for V1 and V3. Okay, and then this total voltage is 12 volt. So I can find the current easily. So 12 divided by, these two are in series now, 12 divided by 8 ohms. Similarly here also 12 divided by 8 ohms. Okay, so I can say directly, if I could solve the total current is divided between these two equally because the resistance offered is same.
Yes, ma'am.
Okay.
Good. Thank you.
Okay, so now, okay, ma. So now another network. Don't look at this network. Don't look at this network. Okay, just I have redrawn the network like this. The network is redrawn like this. Okay, so now these are all the few examples. When you have a complex network, when you look at the network, it may look complex, but if you redraw the network, it will be easy to solve. Okay, so the original network is this. The original network is this. Okay, so I think somebody is getting, somebody asked me ground. Okay, so the indication of these two are nothing but these two are connected together. Okay, maybe I will, don't look at this network, just follow with me. If you could do, you also can try. All of you, please try to have a notebook along with you. Try to do it by yourself. Okay, so now what they have given here, this is given as node A. So I will also take this node A. Okay, so now node A is connected to 6 ohm resistor and this is grounded. Okay, now again, if I proceed here from node A, we have 7 ohms resistor. What do? Since this end of the resistor is grounded, so it's nothing but this is also grounded, this is also grounded. So what is the indication? These two are shorted. So what do? I'll just connect like this. Okay, so this is my 5 ohm resistor. Okay. Now, again, let's continue. So this side, this is E1. This is E1. So what is the value of E1? E1 is minus 6 volt. What is this indication? It is a source. It is a voltage source. Voltage source minus 6 volt. How do I draw the voltage source generally? Voltage source. This is how we draw, right? So this is a positive voltage source and this is a negative voltage source. So here it is given minus 6 volt. So minus 6 volt. Okay. Now again from A, we have another resistor. This is node A, right? Another resistor. And then resistor other end is connected to a voltage source 18 volt. So it's plus 18 volt. So other end of the resistor is connected to 18 volt. That's all. It's done. Okay, so I'm not writing it as minus 6 because I have indicated like this, because I've connected negative. Okay, if I have to write minus 6, then I can draw and write it as minus 6. Okay, so I have drawn the voltage source, negative voltage source, because it is minus 6. Okay, any confusion here in redrawing the network? Any confusion here in redrawing the network?
Ma'am, no confusion, ma'am, but
Okay.
some problem which we have A and B, ma'am. How do you split A and B, ma'am?
Where is B? B is not given here. Which point you are taking as B? Maybe the ground one. Is this you're saying as B?
No, ma'am, not in this problem, ma'am. In general, ma'am, in problems like the free problem where we have both A and B, ma'am. We are A as the first resistor and B as the second resistor, ma'am. But A is the top terminal and B is the bottom terminal, like ma'am.
That's what. Depending on the network, we can assign the variables to any particular terminal, and it will be easy for us to, it will be easy for us to proceed further to solve the network. So as far as this given network is concerned, we are considering this as terminal A, and this is terminal A. And just with respect to this terminal A, I have totally redrawn this network. Basically, what we have done is this E1 voltage source, they have given it as minus 6 volt, right? And plus 8 volt. That's what we have redrawn here. And then this side, since this is also grounded, this is also grounded, just we have connected it together. Then it's just we have connected it together. Obviously, we know that positive voltage source means positive terminal we'll take, and the other terminal is a reference terminal, definitely grounded. When I say negative voltage source, we'll be using this negative voltage source connected to a network or load, and the other terminal will be grounded, which is a reference node. That's what we have done here. As far as this network is concerned, I hope there is no doubt. So you're asking me if suppose I have other terminals, maybe I'll see whether I could take some example. We can solve. I think I have few more examples. I will maybe I don't exactly get you, like if I have A and B. Okay, so here I hope you all are able to understand how I have redrawn this network.
Yes,
okay.
ma'am.
Okay, fine. Okay, so now the question is, from this, you're asked to calculate what is V2, what is V1. So obviously, which is V1 here? V1 is voltage across this. And then V2 is voltage across the 6 ohm resistor, and V1 is nothing but, can anyone tell me what is V1? V1 is voltage at 18, and the reference is A. They are asked to calculate, this is V2. Sorry, maybe I will do one thing. Where is this not happening? I'll do one thing. We'll just do this. Okay, so now quickly I will just redraw. This is my node A. This is connected to AB. What I will do, I'll draw like this. Okay, so 7 plus 5 is 12 ohms. So here I have 6 ohms. Okay, and then these two are connected to ground. And then on the other side, I have my 6-volt battery. And then minus 6-volt battery. And then here, if you consider, I have my resistor connected to 18 volt. Now this is easy. Okay, so this is my node A. This is my node A. I guess I have done it correctly, right? So this is 6 ohm resistor. Now from this question, you find out what is that they are asking. They are asking you to calculate this current. They are asking you to calculate this current. Okay, and then another question is what is V1? V1 is nothing but this. V1, how is that polarity they have marked? This side is V1. They are asking you to, this is V1. I hope I'm drawing it correctly, because the negative terminal they are marking at A. So that's the reason A. This is V1. And what is that? V2 also they are asking. V2 is nothing but across this. Okay, so can anyone tell me what is V2? Can anyone tell me what is V2? Directly, without solving? Very good. Is it 6 or minus 6? Is it 6 or minus 6?
-6 volt.
Minus 6, because V2 is nothing but voltage at this node with respect to reference terminal, whereas here this is minus 6. So V2 is minus 6. Now, can anyone tell me how do I get this V1? How do I get this V1? Expression at least, if I consider this as V6, V6, voltage across 6 ohm resistor.
Ma'am, at 6 volt, 6 ohm resistor, V6 is there, no, ma'am. The negative terminal is same, ma'am. It will be -6 only. Here, okay. Positive terminal will be 0. It is grounded, no, ma'am. So between that A and if you will consider positive terminal of V1, that battery one, it will be 18 volt, ma'am.
Yeah, this is 18 volt. There is no doubt. But the question is the total drop across these two terminal. The total drop across these two terminal. That is from here to here. So now my V, that too they are marking the reference like this. They are measuring the voltage at this side with respect to this. Okay, so they say that it's 18 plus voltage drop across 6 ohm resistor. Because they are asking you to calculate the voltage at node A, and then the other end is this side. Okay, so what is this side? This is nothing but voltage source, no? We have a voltage source here, right? So when they say like this, then it's nothing but this one. Nothing but this one. So if I could solve what is the voltage drop across 6 ohm resistor, depending on that polarity, depending on that voltage polarity, we'll be able to, because this voltage and this voltage, these two are connected in series. So sum of these two voltages will be nothing but V1, will be nothing but V1. So if I have to find out the voltage drop across 6 ohms, what is the solution? I should know what is the current flowing through this. I should know what is the current flowing through this. Then only I can find out what is the voltage drop across this. So how do I solve what is the current flowing through this? How do we solve what is the current flowing through this? So the solution is I have to reduce the network. I have to reduce this network. Now these two resistors are connected in parallel, so which can be reduced to a single resistance. So can anyone tell me what will be this value? 6 into 12 divided by 18. I think 4 ohms. Okay, and this side we have single resistor 18. Okay, so now this is 6 ohms. Okay, so now how do we solve this further? How do I solve this further? How do I solve this further? Anybody? Let me read. I can swap this, no? You can swap this, right? Yeah, now can you reduce this to a single source? Can you reduce this to a single source? Can anyone tell me how is the single source representation?
First will be negative, ma'am.
That's
Next
what.
will be
You tell me
positive.
this is 1, 2. So 1 will be positive or negative?
1 will
I
be
consider
negative,
this
ma'am.
is 1 and this is 2. Can I do
1
like
will
that?
be negative,
Can I
ma'am.
do like that? Will it be correct if I do like that? If I do like that, will it be correct? This is connected over here. This is connected over here. This is my reference terminal. This is my reference terminal. Okay. So here this is 6 ohm resistor. I'm just trying to combine these two sources. Okay. If I try to combine this side, if I try to combine this side, okay. Okay. Or is there any other method to solve it in a simple way? Because this voltage source value is known. Why should I reduce? Why should I go for this complex method? So if this is 6 volt, then obviously here also I have 6 volt and this total voltage will also be 6 volt. Am I right? Am I right? Am I right?
Yes, ma'am.
Yeah.
Yes, ma'am.
Because so this since these three are parallel, there is no confusion in identifying this as a parallel connection. So I have a voltage source in this branch. So obviously here also I have 6 volt, minus 6 volt. Here also I have minus 6 volt. Okay. So I could directly say that this is minus 6 volt and this voltage will also be 6 volt. Okay. And then here also I have 6 volt. Okay. So the question is, what is V1 and what is V2? What is V1 and what is V2? Okay, so V2 is directly minus 6 volt. V2 is minus 6 volt. Since this also will be like this, I have this V2 will also be minus 6 volt. And now the question is, what is I? I'm able to find out V1 and V2 easily. Now the question is, what is I? How do we find out what is I? How do we find out what is I? That to I where they are marking, they are marking I over here. This is the current I. How do we find out this current I? This total voltage is minus 6 volt. And what will be the voltage drop across 6 ohm? Then I can find out the I. Am I confusing too much? Any confusion here? Please tell me. Why my eraser is not working? Yeah, now it's going.
Ma'am,
Hmm.
can we solve this using Kirchhoff's voltage law?
Yeah, everywhere we have, no, I didn't go for Kirchhoff's voltage law and all. Simple Ohm's law only I have
Solve
used.
it using it.
Sorry, Pa?
Can we solve it using Kirchhoff's
Yeah,
voltage?
you can solve using Kirchhoff's voltage law also. See what I have done. This is my 12 ohms resistor. Okay, and then here I have my 6 ohms resistor, and then this is my 6 volt, and then here I have my this. Okay, so now these two are reduced to a single resistor, which is 4 ohms resistor. Okay, and then so now there is no doubt. So the question is, what is V2 and V1? This is V2, which is minus 6 volt, and V1 is nothing but this is V1. So directly I could say that V1 and V2 is equal because they are connected in parallel. V1 and V2 both are minus 6 volt. Now the question is, what is current? Where they mark the current? The current they are marking like this. Okay, so they are marking from E towards minus 6 volt. From A towards minus 6 volt. Okay, what is this current? How do I solve this? This is the question. Am I marking it correctly? Yes, from node A towards minus 6 volt. So this current they are asking. They are asking you to calculate this current. How do I find out this current? So if I know this current and this current, then using KCL, Using KCL, I can find out what will be this current. Okay, so now what will be this current? I know the voltage drop across this is minus 6 volt. The voltage drop across this is minus 6 volt. Okay, here also it is minus 6 volt. So since it's minus 6 volt, the current will flow from higher potential to the lower potential. I mark the current direction like this. Voltage drop across this is 6 volt. So 6 by 4 is 3 by 2, which is 1.5 amps. This voltage drop is minus 6. So obviously this voltage drop will also be minus 6. That's the reason I'm marking the current direction from plus to minus. So here my current is 1.5 amps. Okay. Now what will be the current here in this branch? I have a resistor and then this voltage, total voltage drop is 6 volt, minus 6 volt. And what will be the drop across this? What will be the drop across this? Can anyone tell me? Can anyone tell me? This is A. Okay. Minus 6 volt. And this voltage drop I'm writing as V6. Okay. I'm just considering the current direction like this. V6 plus 18. Any confusion in this equation? Confusion in this equation? I just write the KVL in this loop. So as somebody mentioned, I just write the KVL in this loop. Okay. So here plus 2 minus, here again plus 2 minus, here again plus 2 minus. Okay. So I can write it as 6 plus V6 plus 18 is equal to 0. So what will be my V6? V6 will be minus 24. So V6 is minus 24. So what will be the current flowing through this and what direction? What will be the current flowing through the 6 ohm resistor? V6 is minus 24. So since minus 24, I'll have my current direction like this across this. Since these two are, so 24 minus 6, sorry, 24 divided by 6 is 4 amps. And this current is 4 amps. This current is 1.5 amps. And current direction is given like this in the original network. That is, current is flowing from A towards minus 6. From A towards minus 6. I'm marking the direction like this. So use KCL. This is leaving current and these two are entering current. So obviously 1.5 plus 6 will be 7.5 amps. This is 7.5 amps. Okay. So is it easy to solve? Any doubt here?
Actually, we have a chemistry class right now.
Can you ask a little louder, ma? I'm not able to hear you.
Nearly 9 o'clock, ma'am, and we have a chemistry class.
Oh, sorry. Right. Okay. Okay. Time up. Sorry, ma. Sorry. I didn't notice.
Sorry to interrupt, ma'am.
Okay. No problem. I'll just download the attendance. You can leave that. Very nice song.